Fluent validation also allows for validating complex properties. To demonstrate this functionality, let's expand our example and assume that we need to accept the student's address not as one string, but as an object with multiple properties. Here's our student class again. As you can see, its address is represented with a string here. Let's introduce a separate class for it, which we'll call address. There is going to be street, city, state, and a zip code in that class. And let me also define a constructor that would accept all these properties. Changing the student's constructor to accept the new address class. That was our domain model. We also need to modify our data contracts to accept the new fields separately. For that, I'm introducing a new class, address DDO. This is similar to the course enrollment DDO. It's another nested data contract class. Generating it and adding the 4 fields. Very good. At this point, you might ask, why not just use the same class here, the student domain class, since these two classes are almost identical? That might seem reasonable at first, but in fact, the use of domain classes as data contracts is an anti-pattern. You should always keep them separate. The reason is that they have different responsibilities. The domain class models the problem domain, while the data contract, the address DDO, serves as a public interface for your clients and also responsible for maintaining backward compatibility, so that the clients don't break when you refactor your domain model. Alright, let's finish our refactoring toward multi-property addresses. In the constructor, we need to pass an address instance to the student's constructor. So I first need to create that instance using the data from the DDO. The edit personal info method needs to be updated too. We'll do that later, let me just comment these 2 lines for now. In the get method, we need to return the DDO instance instead of a plain string. And for that, I first need to update the response data contract. Copying the data from the domain class to the address DDO. The next thing is the student repository. We need to update the methods that create our test data. I'm just replacing this string with an object instantiation, and the same for Bob. The last compilation error is the validator class. Let me comment it out for now. Very good. Let's run the application to make sure that the refactoring didn't break the registration functionality. I'm changing this line here to a fully fledged address object. Sending the request, the API returns a success, which means that the registration functionality is working. If I go to the getRequest method and ask for Carl's details, you can see that the API returns the address we provided in the previous API call. So, how can we validate the new address structure? One way to do so in Fluent validation is to validate each field in that structure separately. Let's say that the street's maximum length is 100 characters. Cities 40 characters, states cannot have more than 2 characters, and zip codes should not exceed 5 characters. Let's run the application to see if it works. Making the city an empty string, and you can see that the API has returned a correct error saying that the city field cannot be empty. There is one problem with this code though. What do you think will happen if we set the overarching address field to null? Let's try this out and replace the address object with a null value. And you can see that the validator has thrown an exception because of the null address field. Fluent validation doesn't automatically check for non-nullability of the object container when you set up rules for its properties. We need to ask for that check explicitly using this when statement. This statement tells the Fluent validation library to run the rule only when this condition is true, when the address is not null. Let's run the application and try to send the same request again. We get the null reference exception again, but this time it's not the Fluent validation that throws it, but our own code that assumes that the address cannot be null. This means that the library hasn't invoked these 4 rules, which is what we wanted. But we need another rule here to check for the non-nullability of the address object itself. This line will get us all the checks we need. This is one way to do the validation of complex properties, by first checking the property itself and then setting up rules for its nested properties. It works fine for simple cases, but has a major drawback. We will have to duplicate this code should we need to do the same validations for another request. And we do need these same validations in another request. The Edit Personal Information API endpoint also allows us to specify the student address. For this reason, it's best to take another approach when validating complex properties, by creating a separate validator class and extracting all this validation logic into that class. So let's do that. I'm calling this class AddressValidator. It will validate the address DDO. Copying this code here. We don't need this address field anymore. And no need for specifying these conditions either. Now, instead of these 4 lines, I can use the setValidator method on the address field and pass the new validator here. Let's see how it works. Removing the city property, and you can see that the new validator successfully indicated the empty city as an error. And if I specify the whole address property as null, the validator also returns an error, just as expected. Note that this custom validator will be invoked only if the address property is not null. So, should our application allow for null student addresses, we would just need to remove the notNull method call. The rest of the validation code can be left as is. No need to specify the when condition like we did with separate nested properties. Let me remove this code. Good. Finally, let's change the Edit Personal Info method such that it also works with the new address DDO class. For that, we need to change the type of its address property and create a new validator for the corresponding data contract. The rules here are going to be the same as for the Register API, but with the exception of the email property. The client cannot change the student email after that student is registered. In the controller, we need to instantiate the new validator, ask it to validate the request, and check if the validation result contains any errors. If everything is fine, we need to create an address object the same way we did in the registration method and use it here. And I can remove this to-do item. We have implemented the same validations as in the registration method. Let's check that everything is still working. Registering Carl, and let's update his address. I will change the building number in that address and remove the old string. Sending it, requesting the user data, and you can see that the API has successfully updated Carl's address. And if I remove the street, the validator successfully points out that error. Very good. In the previous demo, we replaced an address string with an address class. Fluent validation has 2 ways of validating complex properties. The first is to list them all in the same validator as nested properties. This approach is simple, but it has several drawbacks. First, you need to remember that all validation rules are independent from each other, which means that this check for street emptiness will take place regardless of whether the check for address nullability has passed. Because of that, we have to specify an additional condition here, that we want the check to trigger only when the overarching address property is not null. The second drawback is that we cannot reuse such validations. In our case, we need the same address validations in the Edit Personal Info Controller method, and the only way to implement these checks there is to copy them over. The second approach is to introduce a separate validator specifically for the address DDO. This is a much cleaner solution because it doesn't require us to add conditional statements, and we can reuse the same validator between different requests. We will talk more about conditional validations later in this course.